to Milano next time.
Thank you. Thank you. I plan to come back.
So as Vivi mentioned that our webinar is a live streaming on the different platforms, so including the YouTube and others. I hope not only the participant in Zoom, also the others would also look at this webinar and to give some ideas about this the topic about the explainable fuzzy. I think it can attract. Okay, so but it can definitely attract more young researchers. Insertion. Okay, so I think based on the time frame, if you are ready, so I would like to welcome everyone to participate in our second webinar. So, and thanks to our publisher OAE and for providing this great opportunity for us to share the knowledge. And that's it on behalf of the OAE publishing company. So I'm trying to start the webinar today. So for today, so basically, first of all, because the webinar is connected to our journal, is a complex engineering system. And this journal now is in the second year. So it was basically, the journal was launched in 2021, and up to now it's more than 1 year. So we are running this journal in the open access platform. So the link to the journal you can see on this page. And as we see that this is a fully open access or the gold open access journal. But the good thing is that up to the end of December 2024, there is no APC for the article processing charges. So you can find the webpage, you can find all the information. And of course, our ambition is to publish the result. So after the review process in a very fast form in terms of to be visible to all the researchers in the world. So the journal is aiming to be indexed in some platform. So this is an ongoing process. So of course, all the information, you are welcome to look at the webpage and to find more information. So the good thing is that, so we have published 22 articles. So at least 4 issues has been published. The first 2 volumes was published in 2021. You can see the 2 topics basically for the last year, the volume 1. And this year also up to now, we have published 2 volumes. And each volume has 5 articles, and basically this is a composition of all the papers published in since last year. So on the top of that, so the more specifically, the latest issue has been published. So basically in the end of June, so you can see articles has been published. So the good thing is that our speaker today, Professor Kelly Cohen, so he's published, so his article about explainable fuzzy cluster-based regression algorithm. So in our second issue of the volume 2, and he's going to provide more information about this interesting topic today. And of course, you are welcome to look at his article, and also the other article has been published. So in the last volume, in the last issue. So the good thing is that for today, so we have a specific topic, and thanks to the Professor Cohen and also Dr. Arnett, so basically they are going to provide more information for us for this very attractive topic. So about explainable fuzzy logic based AI and the potential promise and XFC International Student Competition 2023. And of course, we will learn more about their basic contribution, and also what would be the basic information can be provided to us and how we can contribute to this competition next year. So for today, so as we know that we have 2 distinguished speakers, and my good friend Kelly. So I appreciate his great support to the journal development, and he's also our subject editors. And basically, he's going to address the first lecture today. And basically, the Kelly is from University of Cincinnati. And the second distinguished speaker for today is Dr. Tim Arnett. And he is also the senior AI researcher, and we are going also to listen to his presentation in the second part. So for today, so we have this schedule because of the rough time frame. So I just keep the time. So after my short presentation, so the Kelly, he will take the floor and to give a presentation, and then the Dr. Arnett, and then we have a Q&A session after the two speech. And then if you have any question, please feel free to put your question or raise your hand, and we try to discuss it. So basically after the second speech, and finally is the concluding part. Okay, so because of time, so Kelly, so I can stop my slide, and the floor is yours. Please, you can, if you're ready, you can share your screen, and then we can continue.
A very good morning to everyone, and thank you so much, Professor Karimi, and to OEA Publishing to set up this wonderful webinar where we can talk to you. We've gone through the agenda, and I'd like to thank Complex Engineering Systems for co-sponsoring the competition for next year that Tim would get into more detail on. So I don't want to forget. Thank you very much for your sponsorship. A little bit about my background. I'm right now the president-elect of the North American Fuzzy Information Processing Society. I'm very happy to share that Barnabas Bede, professor from DigiPen, who is the current president of the North American Fuzzy Information Processing Society, is online, and he was an active participant in our competition last year. NAFIS, this organization, is also going to co-sponsor the competition for next year. So when we have the Q&A sessions, Barnabas, please feel free to talk about what you feel about this and NAFIS in general. So, I want to start with a story that took place just about a week ago, okay? Cruise robotaxis. We're talking about autonomous systems and intelligent autonomous systems and the impact that can have on society, right? So cruise robotaxis, we're building these self-driving vehicles to improve life in our cities. They're safe. They've, we're talking about big business here, $30 billion. They're shared, all electric, of course, because it's a start-off. The first time integrating that into society in the United States. The vehicles are restricted 30 miles an hour, only between 10 p.m. and 6. They can operate between 6 a.m. and 10 p.m. They cannot go downtown or onto highways and are prevented from driving in bad weather. Now, what happened? They take fares, passengers, right? What happened was that on the 30th of June, an eyewitness told the San Francisco Examiner that about 20 of them clustered and blocked the traffic. Something had caused the vehicles to cluster together. And while it took about 20 minutes for the maintenance team to come on the spot, it took a few hours for them to manually, resolve the problem and to be able to alleviate these cars. So the question as engineers is that what happened, right? It does not appear to be a singular mechanical failure because the same problem occurred in 20 vehicles at exactly the same time. So what caused this unintended malfunction? Could it be some sort of a software bug? And I'm guessing, okay, because we don't know the real story. It could be something malicious, external intervention, cyber interference, human machine AI interface issues. And now the question to us as societies, would we trust such a system to transport our loved ones? What if that rendezvous point happened to be, somewhere other than a blocked road, somewhere off the Golden Gate Bridge? if you can get a bunch of autonomous vehicles to cluster around a point, now that means you've taken over some navigation system. That could be a problem. And when we are talking about intelligent autonomous systems and scaling that up in order for it to be economically viable, trust is a major issue, right? And we need an explanation, an answer to this why question. And so the pursuit of this why does autonomous vehicles behave in the way they behave is the start of the journey that we are trying to shed more light on. Now, what about policymakers, right? So this is also very recent, June 2022. I saw this about a week ago. The US Department of Defense responsible AI strategy and implementation pathway put together by the Deputy Secretary of Defense. So this is policy. And what does this policy say? Just to summarize, trust in AI from the Department of Defense's point of view will enable the department to modernize its warfighting capabilities across a range of combat, non-combat applications. Okay, and without trust, warfighters and leaders will not employ AI effectively, and the American people will not support it. Okay, so trust is now not just a nice to have attribute. It is not enough to have a black box provide you with a prediction. You want to be able to trust it. And when we talk about trust, we need to validate that. We need to be able to certify that. We need to be able to say, okay, I can assure the public, I can assure the warfighter, I can assure the user, okay, that we can trust this system to do exactly what we want it to do, no more, no less. And so the DoD now is taking its commitment to responsible AI, that's AI, not AJ, seriously, and is actively pursuing methods to make AI implementation safer and more effective. So the shift in the past decade was all about performance. If you could come up with good performance, that was adequate. But now we're going beyond that. We need to ensure that our AI is extremely trustworthy. You can see the schematic from that report. The report is publicly available. We are looking at it from a bigger zoom than we thought possible. Requirements, validation, the trust, and it all funnels down to, okay, we're talking about AI ethics, and then the responsible AI strategy and implementation all funnels down to trust. And having to have a very clear policy on trustworthy AI is, the Europeans have been talking about it. And right now we see that in the United States, this is getting more and more traction as well. The need for explainable AI, DARPA a couple of years ago came up with a program. So they've had the need and they've explored that. Why are we doing something and not something else? When do we succeed? When do we fail? When can I trust you? I'm sure all of you have seen this chart. I don't want to delve into it a bit too much. And we want to get answers. We want to understand that why. Why did these vehicles on June the 30th cluster around a certain point? Why did the system fail? And when can I know that I can trust it? And when has it come up with that sort of a malfunction? So you want to define AI, explainable AI, which is one of the attributes that will lead us to that trustworthiness, right? We'll have the ability to explain the rationale, characterize the strengths and the weaknesses, and convey an understanding of how they will behave in the future. Again, another definition of trustworthy AI from 2019, you want to be able to understand the decisions, you want it to be transparent and impactful, okay? Explainable AI, the responsibility. So a lot of the focus in the past has been on model performance, on decision-making, right? And now we want to go into safety, make sure we can trust it, ethics, accountability, and also regulations. About 6 months ago, this article was published as a result of a lot of work done on the Explainable AI program. And a bunch of co-authors got together and put together a paper that starts off with brittle AI. And in our journey through this program, we have seen several big picture takeaways. Explanations need to be highly tailored to the scenario. Many seemingly high performance reinforcement learning agents are extremely brittle and not amenable to explanation. When you say extremely brittle, do they meet the requirement of trustworthiness? I think not. A lot of the push and success in playing games and chess and that has made the big news about AI and its capability and performance over the past decade has been attributed to these black boxes. And okay, that was not intended. Please mute yourself, dear friend. Casual models allow for rich explanations, but how to present them is not always straightforward. Human subjects conjure fantastically wrong mental models of AI. So when we talk about AI and introducing that to the human, you can see that our perception is wrong. If our perception is wrong, the interaction would not lead to the intended utilization of that technology in the best possible manner. So it is not enough to have one black box do a prediction and another set of black boxes take a look at some sort of sensitivity analysis on the prediction of the first black box and then come up with some interpretability criteria. You need to be able to get a good mental model, communicate that to humans, because when we're talking about large-scale systems, we do not envisage, especially if it's safety critical, not to have the human in the loop. So there would be a supervisor, right? Like what we saw in that case of the robo-taxis. You have a supervisor, you have somebody in a control room looking and monitoring the health of all your autonomous vehicles. And you want to keep that ratio down for it to be financially viable, okay? Advanced air mobility, which constitutes the movement of people and goods in the third dimension, has got a market estimation next 25 years of $1.9 trillion. That's a lot of money. But now can you imagine this cluster of unmanned air vehicles in the air being controlled by something other than its intended use? That can get very scary. So you cannot move forward without being able to address this issue of how do you secure your system? How do you guarantee that the autonomous component is completely trustworthy? So a couple of years ago, in February 2019, IEEE Computational Intelligence magazine came up with, okay, we're looking at explainable AI. What are one of the ways to get there, right? There could be several different approaches. One of the ways is evolutionary fuzzy systems. It's an area of my expertise. I've been working in there. Evolutionary, as in Darwin's principle of survival of the fittest, and some generalization of that concept. And it has been demonstrated that this capability is quite effective. One straightforward way of combining two of the most important concepts in machine learning in a natural way is to obtain this explainable artificial intelligence models by means of synergy between fuzzy rule-based systems and evolutionary algorithms. I started my journey into fuzzy systems back in 1994, so that's about 28 years. And somewhere about over a decade ago, after I moved to the University of Cincinnati, I started automating the rule generation as well as having to determine the membership functions of both the the interfaces that we have with linguistic rules, okay, utilizing genetic algorithms. So we've been doing this for a while. We didn't call it explainability in the past. It was an intuition. It's relatively a small group within the big AI community doing that. But over time, there is also very good performance by these systems. So what does a fuzzy system look like, right? So you have the fuzzification. When we collect data, the data is, well, digital usually. It could be images, it could be, but something, a digitized image, a video, numerical information. There's nothing fuzzy about what we collect. But what we do here, and the term sometimes puts people off. Oh, this is logic. If a politician uses the term fuzzy logic, it is usually in a derogatory manner. But it is a universal approximator. That means if you have an infinite set of mappings between information gathered and an outcome, a decision, okay, it could be a classifier, it could be a regressor. A fuzzy system can, in theory, provide you with that ultimate mapping. So mathematically, we have the capability, but when we decompose that, we get a set of linguistic rules that are explainable, transparent. Linguistic rules as an if-then, right? If it's raining and if I take an umbrella, outcome is I won't get wet. Desired, I don't want to get wet. If I want to do singing in the rain, then I can get rid of the umbrella, right? What is the inference system about? There's the knowledge base. The knowledge base is a part of what the evolutionary algorithm learning takes place. And to this knowledge base, you have the fuzzification, defuzzification, that's the input-output interface. They're called membership functions or gains. But as opposed to gains, say, in a PID controller, which happen to be fixed very often, here they're variable, they change based on the situation. So that provides you with more flexibility and performance. And then these are the set of if-then rules we have. So we learn about these rules from data. We learn from them from, say, simulation, right? And that's what the genetic algorithm does. So it allows you to take this universal approximation architecture, utilize information that you gather, and then come up with a set of rules which are transparent, as well as that interface function, okay? So the attributes of this evolutionary fuzzy system, it's got good performance. So you can get explainability without having to sacrifice on performance, okay? It's transparent, explainable, deterministic, computationally efficient. It's quite simple as far as the mathematical operations are concerned. And so, you could get it to work very quickly and in real time. Tim Arnett's PhD was on verification validation using formal methods. And Thalis has come up with a toolbox in this area for genetic fuzzy systems. Tim, please say a few things about the product that you are developing in this area. Scalable and robust to noise and uncertainties. The reason for that, Tim, is that I want folk on this call to know that this is not just some academic exercise that we are developing here. There is a real value to industry with the type of products can spin off from these ideas, okay? Work well within complete and small data sets. Now, this was again prepared by the IEEE Computational Intelligence magazine, where they showed that deep learning neural nets can give you good performance, but very low explainability, whereas fuzzy rule-based systems have the potential of providing you with good accuracy. And some of us claim that this desired value can be out here. So we could give you very high performance while providing good explainability as well. And these are some of the other state-of-the-art systems there. So the lab that I have just started up, I moved into this position very recently as the director of the AI Biolab at the University of Cincinnati. You can see trustworthy AI is front and center of what we're doing, but we're coupling that also with human performance augmentation. We cannot just look at algorithms for what they are. We need to be able to connect them to a system and tailor that integration effectively to create value. And our applications lie within DoD, health, transportation, and I can even project that into energy, food, water, and other important things for society. Some of the areas that we are working on, I have divided this into medical and non-medical, military, civilian, the work I do at the University of Cincinnati, and this is an offshoot of the University of Cincinnati called Genexia with Mr. Dino Martis. You can see that we cover a wide spectrum. All of that is in this arena called complex engineering systems. In the civilian side, you can see CVG is the airport here at Cincinnati, passenger flow prediction. We've patented this, and this is going into being developed as a product, cooperative driving automation, a wide range of applications that we're working with. This is AAM is Advanced Air Mobility. This was done in conjunction with Crown Consulting when we worked on a center proposal. You can see the foundations of AI. Barnabash Bede was part of this effort. Automation that can mimic human intelligence in areas such as thinking, problem solving, decision making, and learning. Explainable, trust, confidentiality, security, scalability. These are the barriers that one has. And then we want to utilize and introduce these enabling technologies that is real-time learning, collaboration, explainability and trustworthiness, human AI interaction. And then the barriers to this is extension to real-time assurance, dynamic environments with unknown unknowns, human control, monitoring and situational awareness. These areas are not solved today. They are things that would allow us to get to assured autonomy in the next decade or so. And then the test bed that we are looking for is having to control, manage the aerospace, optimize route planning, energy resource management, conflict detection, resolution, monitoring. These are system requirements that would come in and help us create these areas. So if I look at my area of expertise within complex engineering systems, I would foresee developing special issues in these areas and encouraging people to submit papers, which I feel that would have a big market for industry, for investments, because if we resolve these issues, the economic benefits are huge. If I look at the advanced air mobility, if I look at autonomous driving, the problems haven't resolved. They have been underestimated as far as their complexity is concerned. But in order to be able to get there in the area of health, in the area of safety critical systems, transportation, we need to be more engaged in these problems. Now, I'll conduct a Q&A session after Dr. Tim Arnett's talk. I do have 2 minutes to just introduce Tim and the topic itself of this competition. So this competition was Tim Arnett's brainchild. He came up with that, and 2 years ago it was initiated, first in a relatively small scale, and now we're trying to blow that up. The idea is to get students engaged. We want students to be engaged in this set of problems and to engaging these barriers. How better to engage students than to introduce them to it, right? So today, you could get a degree in computer science at many institutions without even hearing the term evolutionary fuzzy systems or explainable AI for that matter, right? It's all about performance, performance, performance. But that's not enough. The world is changing. The policies are changing. You need your students to get engaged. You need the community, the younger generation to be able to work out real issues that would be able to advance our society. And how better to do that than to engage them in an international student competition focused on explainable AI, focused on ability to increase your tools. So over a course of 1 year, from September to April, we invest in students. What does it cost? Well, you've got to have your laptop, you've got to have connectivity, and you've got to invest some time. That's it. And the rewards are knowledge, ability to engage in a very fruitful market, and also possibly winning some of those prizes that are offered today by Thales, by Complex Engineering Systems, and by other sponsors that we hope to have. So having said all that, I would give the floor to Dr. Tim Arnett, the one and only. Tim, all yours, and you please share your screen.
Thank you, Kelly, and thanks for the brief introduction to the competition. Let me share. Okay. Okay, is that coming across? Can everybody see the presentation? Okay.
Tim, this is very good.
Thanks, Kelly. So as Kelly said, I'm going to be talking about the Explainable Fuzzy Challenge competition, which is a competition for students. This is the third year that we will be doing this. It's being run with affiliation with NAFIPS, the North American Fuzzy Information Processing Society. University of Cincinnati has been contributing in support with respect to efforts and other material support. Thales, the company that I work for, is one of the sponsors of the competition, along with now Complex Engineering Systems that is also sponsoring this year. So what I'm going to go over is the motivation and goals behind the competition. Kelly alluded to some of that, but we're going to talk a little bit more. Then go over the competition itself, including a thorough description of what it is. We'll talk a little bit about the results from the first year, and more specifically this past year, where things were more fleshed out. And then we'll talk about this year's competition, the changes that we've made, and a bunch of information for people who might be interested in either competing, sponsoring, or getting involved as a volunteer to help out, all of those things. So what is XFC? This is a competition using fuzzy logic and machine learning methods to play video games. Last year was the second annual competition. The first was in spring of 21. It was just the one semester, whereas last year was the full academic year. And what this is students create an AI agent to control vehicles in the Python arcade game Asteroid Smasher. And I'll explain what the game is in a second. And as Kelly said, there's a much larger focus on explainability in these types of systems. And so there is a focus in this competition of the AI agent that they develop explaining its actions throughout a simulation run or multiple runs. In addition to this, seminars are given to the students throughout the fall semester. These include seminars on things like fuzzy logic itself. We've had multiple on fuzzy logic, including explainability and fuzzy systems. We also give them seminars on gradient-free optimization with a focus on reinforcement learning. And these include things like genetic algorithms or other evolutionary strategies, particle swarm, those sorts of things. We've also given them one on gradient-based optimization. We would like to expand this into more gradient-based reinforcement learning methods if there are experts in the audience that would like to contribute in that way. We are not doing that right now, and there's no limitation on the learning systems themselves in this competition. There are limitations on other algorithms they can implement, however. The challenge culminates in a competition where each agent is evaluated live in the game. They're evaluated over a large number of different scenarios, and there are a number of scenarios that we actually show during a live stream. So it's this interactive thing where we stream some of the live results and show the performance. We talk with the teams, and you can see these on our YouTube channel, which I'll provide the links for and show you in a bit. The explainability of the agents is currently being judged by a panel of human judges, and they're evaluated over scenarios designed to elicit particular behaviors. And so these are situations where you really care about what the agent is doing and why. And the human judges assign scores in a bunch of different ways, or they use a bunch of different metrics to evaluate the explainability of the agent. There are monetary prizes for the winning teams. There are awards for performance, most innovative, et cetera. The past 2 years, the total prize pool was $3,000 USD. That is increasing slightly, it appears, but that it's going to be around that amount. So some of the goals behind the competition, in the shortish term, we want to foster student development of their skills relating to many different things, but specifically things like Python and object-oriented programming and software development. That's one thing that even a lot of students that get exposure to machine learning or AI systems don't get is software development skills, which is really a massive enabler for being able to do these things more efficiently. Additionally, repository management, machine learning, including reinforcement learning, gradient-free optimization, application of fuzzy systems, explainability. One of the big things is project management and teamwork. I was involved with a number of very intense competitions as a student, and those were probably some of the most valuable experiences I had with respect to developing both hard and soft skills outside of the curriculum. So we really want to push that a little bit more. And presenting to audiences is always good. Longer term goals, well, disseminate these skills into the workforce and research areas. We want to increase those skills and improve XAI and fuzzy adoption and understanding. A lot of people don't even know what fuzzy logic is. Dr. Jerry Mendel gave a great talk at an IEEE conference last year on why fuzzy is not as well known as a lot of other machine learning and AI methods. And so we really want to push more adoption and familiarity with fuzzy. So I will say a few brief words about Talus, the company I work for. We have a number of AI efforts worldwide, including 30 years of experience in AI. We do have a huge focus on transparent, understandable, and ethical AI within the entire company. Our office in particular here in Cincinnati, Ohio, in the US, we have a focus on our genetic fuzzy tree methodology, which I put a link in the chat for. It goes to a page on our toolkit that we offer. And we are a leader within Talus for explainable and verifiable AI, especially for mission and safety critical systems. And so some of the examples of things we developed, on the right, we have this graphic from an article on Alpha, which was a genetic fuzzy tree based AI for beyond visual range air-to-air combat. Some of the other applications and use cases we've done, we do biomedical things. This is from a lithium effectiveness study. And also we disseminate our tools throughout Talus, and other offices have developed solutions, including this bidirectional translator for pilots, where it takes pilot intentions, translates that into routing metrics, and then vice versa. So you can say, I would like to select a route that is, half safe, but half fuel efficient, and things like that. And we've seen a lot of success within our company doing this. We have been a sponsor of XFC since its inception, including the monetary prizes. And we will continue to do this. So the organizers of the competition include Dr. Javier Viana. He's a postdoc researcher at MIT. He just defended his dissertation at UC. Lynn Pickering, who's also a PhD student at UC, myself, I'm a senior AI researcher and verification lead here at Talus, and also Sam King, who just joined the XFC group to help out with general development of our competition. Okay. Sorry about that errant slide. So to get more into the game itself, Asteroid Smasher is the game that they have to develop the agents for, and it is this Python arcade game. You can go see it here. It's an open source game. You can even modify it, which we did. We modified this to be able to do multiple agents, be able to be run constructively, that sort of thing. Pre-DOF simulation, so the vehicles can only rotate, move forward and backwards. They can also fire projectiles in order to hit asteroids. The asteroids then break up into smaller pieces, and then eventually they disappear once they are hit when they're the minimum size. Any piece of the asteroid contacting the vehicle takes a life. Each vehicle has 3 lives. And the overall goal is to destroy all the asteroids or as many as you can before either losing your life or hitting the time limit. This is an example of the timeline, the general timeline for fall semester. This is from last year, but this year we'll be following a similar schedule. In early September, we have a kickoff, which is a presentation describing the entire competition and to get everybody familiar with the organizers and all of that. We followed that up with an introduction to Asteroid Smasher itself, where we have a repository where we host our modified version of Asteroid Smasher. We get everybody to install it and play with it. You can still play it as a human. You can use the keyboard and play the game manually. But then we also then get into how to use Asteroid Smasher along with machine learning methods. We then do seminars, including a seminar on fuzzy inference systems in general. So this goes through all of fuzzy logic and then how to use fuzzy logic for inference and what that means in the context of explainable AI. We then get a seminar. Well, last year we had a seminar on explainability in fuzzy systems from Jerry Mendel. That may be repeated, we're not sure yet, but regardless, we will have a seminar on explainability. We also do a seminar on genetic algorithms and other gradient-free methods. Dr. Barnabas Vede gave a talk last year on gradient descent for fuzzy systems. We'll likely ask him to repeat this, and maybe we'll add another seminar on reinforcement learning using gradients. One thing we did last year was we had a scheduled help session, and this was just general help for students, student teams that were struggling with various aspects of the competition. Typically, it comes down to very technical things in coding or repository management, things like that. But we hold these throughout the year. They're not always scheduled, but we do have a Slack that all of the student competitors join, and they can request help sessions from us throughout the year, and then we schedule them as needed. We then went through a more thorough introduction to the competition, including the format of the competition day, et cetera. For spring semester, what we did was we had another kickoff and help session immediately after getting back from winter break. We then made the teams qualify for the final competition. And really what this was just ensuring smooth integration of their code so that we could run everybody's code correctly and it at least could do simple scenarios. That's all that qualifying entailed. It was really just to make the final integration more smooth and a final check on progress. And then they submitted their final agents to us the week leading up to the competition. This year, the competition, what we did was the students all gave presentations on what they did. They got, I believe it was 10 minutes this year because we only had a handful of teams, but that'll be dependent on the number of teams. And then we evaluated each of their agents over a bunch of scenarios on a live stream while interacting with them, talking about what they did. It's really a lot of fun, especially getting to see all the agents finally playing the game. Another thing that we do is we have milestones that we give them in order to sort of check their progress throughout the year. This year they're optional. We'll probably keep them optional, just highly recommended because they really provide you with a good yardstick for where you're at. And so some of these involved Asteroid Smasher, just getting it up and running. That's what the Hello World one was. We had another one where we had them implement a FIS, just whatever FIS, fuzzy inference system in Asteroid Smasher just to get it working, and then do a very minor thing with FIS optimization. We'll likely keep those. It's always a balance between getting them where they need to be in the project while also not giving them homework. This is an extracurricular. So the competition itself was live streamed on YouTube. You can view this on our channel, which I'll show you in a bit. We had 2 teams compete at the competition itself. We started off the year with about 10 teams that dropped to 2 by the final competition. So we're looking for more student teams to get involved and participate throughout the year. Let's see, explainability. Like I mentioned, the solutions were judged on their explainability by a panel of human judges. And what they did was they assessed the quality and presentation of the explanations from the AI. And there were a bunch of different metrics that they used to base the score on. Some of the scenarios that they were evaluated over, they were designed to elicit certain behaviors. So evaluating how they selected targets, which asteroid to either shoot at or run away from, or those sorts of things. Then also a bunch of different types of scenarios where we had the asteroids in a bunch of different configurations to force the vehicle to either move or shoot. And the explanations were based on that. So if it decided to shoot, let's say this asteroid versus this asteroid, why did it do that? Because, from our perspective, they're essentially the same. Those sorts of things, we're really looking to increase the explainability aspect of the competition as well. And this year we'll likely be moving to something more akin to what's called shoutcasting, I believe, in esports, where we have the explanations coming out of the agents, but we're using that to basically show what it's deciding real time. The overall scoring for the competition is based on both performance, explainability, and their final presentations. The performance scores were based on the number of asteroids hit during all of the scenarios evaluated. And then there were, conditions for tie breaks and things like that. And that was 65% of their overall score. The explainability was 25%, and their final presentations were 10%. We do have highlights, which I'd like to show you. Let's see, I'll have to change my share. Okay. Oh, I may need to share my sound. Okay. So this is a short video of some of the highlights from this past year. So these are the actual agents created by the students, and the scenarios being evaluated during the competition live stream. Okay, I would like to thank Zach Phillips, who created that.
I have
video.
a second speaker thing up that I am closing from the WebEx, so I don't hear you guys, but I may be asking you guys some questions throughout, and I'll hold the mic near the speaker.
Sorry about that. I was getting audio from something else. Okay. So yeah, I'd like to thank Zach Phillips, who's also here at Tallis, for creating that highlight video. The results from the competition this year, first place went to Team Hot Fuzzy, which had 2 students from DigiPen, and then second place went to Team SAU, which was 4 students from a university in India. And then we also gave prizes for the most explainable solution, most innovative, and most computationally efficient. Those criteria and prizes will probably be similar this year. They may not be exactly the same, but we'll talk about that during the kickoff. You can see the results from the competition on our website here. This is XFuzzyComp at Python Anywhere. This has a bunch of stats and data on the performance of the team's agents throughout those scenarios, some of which we saw in the highlights. We also have a YouTube channel here that has a bunch of videos, including recordings of the seminars, the competition itself, help sessions, a lot of these things. So you can go there and see those. I'll have the links at the end, and I'll actually show you what they all look like, including our main website. So the roadmap for XFC overall, the first 2 years, the first year was a single semester. It was a very simple asteroid smasher game. It was just a single agent just trying to clear out all the asteroids. This year we had 2 full semesters, and we changed it to be multi-agent, as you saw in that video. And it was not adversarial, however, they were both teammates and they were both trying to clear all the asteroids. This year we are moving to adversarial. And what that means is there will be another agent in the simulation that is not a teammate. Its interests are not aligned with your agent. So it's either trying to get a better score than you, or actually do things that will hamper you or potentially get rid of your agent. We are also getting more NAFIPS involvement with the competition. We are improving the explainability portion as well, and working to improve the organization of the competition itself. Some of the things planned for next year, ongoing improvements both to explainability and the seminars. We're also looking to modify the game even more, which might include things like power-ups, game modes, etc. We are looking for advice and input from anybody that would like to give any. So feel free to contact us. For future XFCs beyond that, we are considering different games to be the focus of the competition. These might be things like strategy games or RPGs, things that use more clear-cut decision-making to focus on explainability, but that's still an open question. We haven't decided anything there. But XFC 2023, so this year, it'll begin in early September. It won't be late August. It will be early September 2022. It is open to any university level student. Teams are encouraged but not required. You can do it by yourself if you'd like to, but we do have a limit of 6 students on a team. The competition will be held, so this has actually been decided. It will be spring, it won't be late fall. We are not condensing to a single semester. Apologies, this slide was made before that was decided. It will be in spring, likely late March, early April. We're also looking for volunteers to help organize. Anybody that has software development expertise, researchers that would like to give seminars on things like reinforcement learning, fuzzy, explainable AI, machine learning, all those things we're looking for more contributions for. And also things like day-to-day organization. Basically, all the organizers right now are volunteering their time to do this. So anybody that would like to get involved, we will happily talk to you. Registration will be active. We've actually already made it active, so you can go register right now. And we will be emailing things to people who register basically immediately, but also throughout the year. Again, check the website for more info. I'll show you what that looks like in 1 second. Again, it'll begin in early September. Announcements will be put on the website periodically. We also send out emails, and we have a Slack. That is, most of the communication happens through Slack. So all the student competitors join the Slack. We put updates in there along with general help and other things. There is no registration fee. We just want your intent to compete. That's it. And the registration has that. The schedule, one thing I would like to highlight is that the schedule lines up with the semester-based academic year, begins early September, ends early mid-April. So this aligns nicely for use as something like a capstone project, senior design, or just a full year project if you have a course that you would like to make this a part of, or make that option available. That's one reason why we want to keep the schedule similar to how it is. For future XFCs, there will be a larger focus on explainability. We may look into doing things as using the developed AI as an advisor for a human player. The metrics for the explainability have previously included things like user satisfaction, sufficiency of detail, understandability, things like that. But we may expand that to be other things. And really what this all boils down to, like what Kelly was talking about, is trust in the system. You know, do you trust your system to clear out this asteroid field? Don't know. We don't want to prescribe methods, however, to such a degree that it harms results. And so it is this balance between those. We also, like I said, we may switch to games more conducive to useful explainability. And on that topic, there are some potential games that we have identified, but in general, there are certain properties that they would need. So they need an open license or one that allows us to use and modify it as needed. Open source or Python API, much preferred. Conducive to reinforcement learning with manageable state and action spaces, or at least we're able to use some subset of those for like a portion of the game without having to have the agent play the entire game. And also lightweight enough to run on student accessible hardware for reinforcement learning. That's one of the big things. We're not going to have some super high fidelity simulation environment that takes hours to run a single simulation run through. That's not gonna work very well. But two of the ones that we have identified that might be on the docket for future competitions are StarCraft 2. This is one that's popular in a bunch of reinforcement learning demonstrations. We're also looking at FreeCiv, which is an open version of Sid Meier's Civilization games. This one is very complex. The state and action spaces are absolutely huge. However, we could have AIs that could play a portion of these, and the explainability aspect of these would be easier to demonstrate than on something like Asteroid Smasher. But we're open to suggestions. This is a living, breathing, changing thing. We're not set on Asteroid Smasher necessarily. It is a nice bite-sized problem, though, for now. So if you have other suggestions, please contact us. If you want to be involved, please reach out. I'll have our contact info on the last slide. Again, we're looking for any and all volunteer help, including software development, general organization and logistics, social media. That's a big one that we could use someone. So if you're big into social media, please contact us if you'd like to get involved. We would like to have a much bigger social media presence than we currently do. Seminars on relevant topics. I've already said this multiple times. And again, sponsors are also welcome. We currently have 2 sponsors, one of which is CES, and we also have Tallus. So I'm going to leave this up for now. This is a bunch of information and links. We have the organizer information, myself, Lynn Pickering and Javier Viana and Sam King at University of Cincinnati, and their email addresses. This is our website. It is just hosted on our GitHub. And then the performance results, this is just a bunch of stats and figures on the agents being run through the competition, our YouTube channel, and our Slack for if you actually join the competition. So what I'm going to do right now is briefly switch back to my browser to show you the main website. And then we'll open it up to a discussion and Q&A. So this is what our website looks like. If you go to the site, it'll take you to this homepage. There's a big button up here for registration. And if you click on this, it will take you to another site to fill out the registration form where you can have your team name, you list all of your team members, and we are asking that you have an academic advisor. So we'll need the advisor's name and email, and that's it. We may gather more information from the student teams throughout the year, but to just register for the competition, this is all you need to do. And we have a bunch of useful things in here. We have rules, frequently asked questions. We have the schedule for the 2023 season. We have a bunch of things like the results, contact info. Basically everything you'll need is on the website, and we'll be updating this even more. This is a brand new website. We're adding more to it right now. We'll also put notifications on here. So periodically check this and we may have new information. But generally the information on here is accurate and the changes will be minimal from now until the start of the competition. Real quick, I'll show you what the results website looks like. This is the this site where we host all of the stats and figures from the competition. And so you can see a bunch of stats on the total evaluation of their agents throughout all scenarios. This is what the summary is. You can also, though, look at individual scenarios, all of them that they were evaluated over, and you can see the stats and different metrics for each of those. So let's check something like this. Well, if it'll load. Of course, nothing works when you're trying to show it. But yeah, it'll load a bunch of different things, like the asteroids that they destroyed over time, the number of active asteroids in the simulation over time, and all these things. So you can check out some of the results from previous years, and also our channel on YouTube. Our channel is just called Fuzzy Competition, and has a bunch of things like highlight videos, seminars, the competition live streams, a lot of really useful resources. Okay, I'm gonna go back to the presentation. Okay, and with that, I would like to open it up for Q&A.
Barnabas, would it be possible for you to give your insights? First, start about what is NAFIS about, and that NAFIS has endorsed this competition, and your experience as in monitoring and mentoring teams, as well as your interaction with this competition.
Sure, thank you very much. I'm glad to do that. Thank you. One moment, I'm starting up my my stuff. Yeah, so it was a great experience to be able to participate in the competition. And the first year in 2021, I was a judge. And then in 2022, I was involved as a student, an advisor for the team Hot Fuzzy. Yes, from DigiPen Institute of Technology. So they were working throughout the year in on the competition and they were also enrolled in my class. So that's basically underlining what the team was saying about the good alignment with excellent match with academic year. Yeah, so it was great to have them in this competition. Yeah, they had a blast, so they were super excited about the competition from the very start, and they were working really hard to basically yeah, through the milestones and everything. And yeah, they learned a lot. So they had yeah, now they are not here. They are still sleeping probably. Pacific time is is still a lot earlier than Eastern time. So yeah, but I'm a morning person, so for me it doesn't matter. So that's about the team. They learned a lot on software development, on basically object-oriented Python libraries, reinforcement learning, fuzzy systems. So they learned a lot of things. It's a pretty good learning experience from the point of view of both the students and the advisor. So that's one thing. Another thing that Kelly mentioned, that I'm now currently president of the NAFIPS, North American Fuzzy Information Processing Society, is basically the organization that organizes the conference NAFIPS. It includes researchers from North America and Brazil as well. Yeah, so we just had a great conference in Halifax, Canada. Yes, in NAFIPS 2022 was organized in Halifax, Canada. It was an excellent opportunity to meet Tim, for instance, and Kelly online for the competition. It was still organized hybrid mode, and yeah, we had participated with DigiPen students from the team Hot Fuzzy, and they have great experience from there. Also, they learned a lot from the talks. They got excited about continuing their research in Fuzzy. This year I might have teams. I don't know if we will have really a new team competing, but yeah, I hope that I can get a student team again. A different team makes more sense to have competing for next year. Yes, maybe a next year competition. Also, I want to advertise here just real quick, but Kelly will probably do that as well. We are organizing NAFIPS 2023 in Cincinnati, Ohio. Yes, so Kelly is the general chair of the conference. So NAFIPS 2023, please mark your calendar and come to the conference. It's going to be a great experience in-person conference after some years of COVID. We are hopefully back in person. Yeah, so yeah, let me know if you have any other questions to me. Thank you, Kelly and the team, for the great presentations, and I'm glad to join this year again for talks. Thank you.
Thank you, Barnabas.
Thank you, Barnabas.
I look at the chat. There are a couple of questions there. Thanks, Jennifer, for your comment. And then John Fury, you said, is it correct to say fuzziness is required to increase explainability while retaining generalizability and robustness? Well, it's not a requirement, fuzziness, but it's an approach. It's a promising approach that helps you provide that explainability while retaining generalizability and robustness. It is an effective tool in a repertoire of tools. We wouldn't claim exclusiveness in any shape or form as a requirement, because that would make it a bit too much of a, like, you know, it would be incorrect to say that's a requirement. But what we do find that it is a very viable approach. I hope that answers your question, John. If you have a follow-up on that, I'd be happy to talk. Please speak there.
Yeah, sure. Thanks, Kelly. Yeah, so my interest, my team's interest is in finding ways, approaches that we don't have to provide so many examples to our AI. I mean, we're already providing some tens of thousands to millions, I guess. We don't want to collect more data it's like shoveling coal into the old steam engine. It's great to develop automated ways to shovel even more coal into the steam engine, but it'd be even better to have a different kind of engine, I guess. And so, like I said, we're looking for other approaches, and fuzziness, I think, is, as you say, promising. And I don't know of any other approach that claims to increase explainability, while doing that. Over.
Thank you, John. I've worked on several use cases where the database has been relatively very small. Dr. Nick and Ernest, who works with Tim Arnett and Thales, chief architect of Thales USA, he worked on bipolar disorders and brain concussion based on clinical trials that were run by the College of Medicine at the University of Cincinnati. And those are very, very small sample sizes. We're talking about less than 100. And we did get some very promising insights. So the idea is that rich data would allow us, if I look at a kid, how many chairs will a kid have to see before he says that's a chair? How many tables will a kid have to see? You don't have to bring to him necessarily 100,000 tables or chairs. They figure these things out. And so the ability of a human to be able to recognize objects with just a very few examples is there. So the question is, if we are trying to emulate human reasoning and human identification, we should at some point, using explanations, using interfaces, using the purpose, what is it for, right? Because usually a kid sees a chair with respect to what you do with it. You sit on it. It's got interfaces with one's back, one's behind, one's arms. And there are different types of chairs, the baby chair, the big chair, the stool, and so on. And I do feel that our ability to learn from small data sets is one of the ways in which we need to go. There was this big move towards big data. So everything had to be big. And not always, and not in every application, can you get access to annotated data, which is of that large size. It's very expensive and at times impossible. Does that answer your question, John?
Yes, very good thoughts. Thanks.
Yeah. Okay. Is there another question in the chat? Thank you, Casey. Tim, do you want to say something about the product you'll have on, could you put that on the website, on validation, verification, genetic fuzzy systems, the one that Thales has come up with? Because I think that would be of interest. It's a product, I believe it's open right now.
Tim, you are muted.
Yes.
Oh, I'm sorry. Thank you for that. Yeah, so we have a toolkit that is on offer currently to anybody. The licensing details, we could get into, but we also have a brochure that you can download to read more about it. So if you go to the bottom of the website, you can go to this link and get the brochure with more technical details. But our toolkit is based on a methodology called the genetic fuzzy tree. And really there's a large focus on using it for critical and safety and mission critical use cases, because we have some interesting characteristics and other properties that allow us to do things like formally verify the results. So when I say formally verify, what I mean is essentially we can make mathematical guarantees on behavior of the AI itself. And so it's not as simple as just doing numerical evaluation, but we can actually say, no, it doesn't matter what the input is, your system will never do blank, or it will always do blank. So that's really been a big focus, while also retaining the explainability of fuzzy, especially in fuzzy tree configurations, while also really increasing the scalability. So the typical rule of thumb for the number of inputs that our GFTs can handle is high 3 digits, low 4 digits numbers of inputs. So not necessarily on the scale of some of the largest deep learning systems or CNNs, things like that, but definitely much more than traditional fuzzy systems, which are limited to a relatively small number of inputs. So really, it's occupying this middle ground of transparency and explainability, verifiability, and performance. So really trying to balance all of those things. I will say that our toolkit in particular is extremely computationally efficient. It's able to be run on edge devices. We're currently working to improve that even further. But we're talking about evaluation times of single fuzzy systems on the order of tens of nanoseconds. So it's extremely computationally efficient, which is conducive for all sorts of machine learning problems, but then also evaluation times if you care about embedded systems. So the website goes into some of the details about the methodology itself, what it is, what we do with it, all these things. We have more information, including the brochure and other things we could do. If anybody would like to set up a call, please contact me and we can talk more about if it's a good fit for you.
Thanks, Tim. Any other questions you'd like to ask Dr. Annette or myself about explainability, or share your ideas, your thoughts, work you're doing in this area, insights you have?
So Kelly and team, thanks very much for this very informative presentation. Actually, I have one question. So because the team, he mentioned about evaluation, and also you mentioned that one of the criterion is that the agents evaluated over 66 scenarios. So the first question is, could you please a little bit elaborate? So what could be these kind of scenarios if the team or the teams would like to consider in their programming, or a little bit about the evaluation? And maybe very briefly, if you have some ideas about, you mentioned about the evaluation committee. So they will look at all the results, and you would like to check it out in the practical aspect. So do you think you would like to test all of these algorithm in the real case, or just the simulation is enough for this case? Thank you.
Thanks for your question. So I'm going to address the second part first. As far as implementation on real systems, if I'm understanding the question correctly, that is right now outside the scope of the competition, mainly due to just the difficulty and amount of time it takes to translate one of these agents to an embedded system on actual hardware. That's a fairly big step that takes a lot of time. So we're especially for students, we've had students participate in the competition that are first and second year university students. I'm not going to say they're not capable of putting things on hardware, but we want to keep it to such a scope that it's approachable. You can do it while also having a full class load, those sorts of things. I would love to see some of these things being put on actual hardware. But yeah, currently that's outside of the scope. We can definitely talk about maybe expanding the competition to hardware, or maybe having an offshoot competition or an advanced class that is that. I would definitely be open to that for sure. With regards to your first question about the scenarios, when we are talking about scenarios, we're talking about the configuration of the initial conditions for the agents and the asteroids. So one scenario might be a particular configuration for those initial conditions with a few asteroids, only one agent. You saw in the examples that we had one scenario where there was a ring of asteroids that was closing in on the vehicles. There are other ones that have, just random asteroids. There are ones that are trying to force the agent to do particular things. Really what we're attempting to do is to get really good coverage of the space, because you want to be able to evaluate it over as much of the space as possible, while also balancing that with having fun, not making it too easy for the agents. Let's put them in a tough situation and see how long they can last. There are certain situations or certain scenarios that we evaluate them on where it's extremely unlikely that they will actually survive. But it's more, how well can you do until you die? That's always a fun scenario to watch. Again, we're open to advice if someone wants to see very particular scenarios, especially for explainability. We had a number of those that were designed to evaluate certain aspects of the system's explainability. So if you chose a particular asteroid to target, why did you do that? Or why are you trying to avoid currently, instead of just shooting it? Why did you move to this region instead of some other region? All of those things, which might be interesting to know. Let's say that you were using this agent to train a human player to play the game. You would want to know those sorts of things in order to translate that, that knowledge that it learned.
Okay, thank you.
Absolutely.
If I don't know if I could add one thing, our team was training only on random scenarios, so randomly generated asteroid with different number of asteroids. So the number of asteroids was also different from run to run, but it trained on random scenarios. So my advice was to the students, we have no idea what the team will throw at us, so let's just train on random and see how the agent learns from there. Thank you.
I'll simply add that, that goes back to coverage during your learning process. And if your random scenarios give you really good coverage, that may be all that you need.
Mm-hmm. Yep.
Right. Are there any other questions? Discussion
I had
points?
discussed this with Professor Karimi, the possibility of having a special issue dedicated to the competition, successes, different approaches over the past couple of years, just getting people's insights. And Professor Karimi, do you want to say something more about your invitation to Tim to have this special issue on the competition?
Okay, thank you. So sure, actually the CES would be happy to give a more contribution to this exhibit, to this competition, of course through the co-sponsorship in cooperation with the Thales. Of course, the second contribution could be providing the platform. So as Kelly, he mentioned that, so we would be very glad if you would like to organize such a special issues. So, or maybe if you think that you have some sort of this review articles from the previous competition, if you would like to publish, so in our journal, so we are very welcome. So when it comes to the special issues, basically, so if you have some sort of the information, you could either send it to me or to the journal office so she can also provide some information. So from you, try to advertise it in our journal. So it means that either going to such an informative article as a sort of the review of the history of this competition, or what happened, or what kind of the result achieved in the past, and looking forward, we can put it in the new special issue and the CS would be happy to provide this opportunity and to contribute to this competition. So this, of course, you are very welcome to discuss with us further step.
Yeah, thank you,
That would be
Professor Karimi.
fantastic.
Yeah, I was thinking of, in addition to having the point of view which you have on the website of the organizers, to also provide the participants and the judges, like having Barnabas. What is his perspective as a mentor, as a judge to this competition? What are the outcomes that he's looking for their students? The professional society, why is this important for us to endorse? So Barnabas, do you think this would be a good idea as well for you to contribute?
Yes, definitely. Yes, definitely. I'm glad to contribute, and yeah, and I'm excited. Thank you, Professor Karimi, for providing the framework in the journal as well. And thank you for. I don't know if the next competition will be in the NAFIPS conference also highlighted. So
well,
yeah, so that's probably a really good place to increase coverage for the competition and for NAFIPS. And thanks everybody for that.
yeah, we'll have a special session on the winners of that competition when we host the next conference in the end of May. 30th of May it starts, and then we will also have the prizes being awarded at the banquet of that conference. So a special issue, we don't have to wait for another year for it to come out. It's based on the past experiences, but it will provide different perspectives. What do you see here as a mentor? Why is this important to introduce to your students? How do students feel about it? What do the organizers feel about it? So, and then of course, the details on, what were the winning strategies and so on. So it'll be an additional reference for you to, because complex engineering systems is open access, so that you could be able to provide a link to those papers in your website as well.
Yeah, I'm glad to contribute. I'm on. We will discuss details, and I think that I will also encourage the students to basically write their method to convert their basically their competition entry into a journal paper. And yeah, I will encourage that, because they had quite innovative ideas. We won the innovative prize, so yeah.
Thanks, Barnabas. Tim, do you want to summarize this with anything, and then I'll pass that on to Hamid to be able to wrap it all up. So Tim first.
Yeah,
and then
I'll just summarize by saying this is a competition that's open to any university level student. We don't care about major or previous experience. There is some base level of experience as always, but we give seminars on a lot of relevant topics. We encourage diverse teams, not just all one particular major. We have seen good outcomes from really diverse student teams from a bunch of different fields. The overall goal of it is to increase students' skills while, also somewhat selfishly getting some of these skills disseminated into the workforce, getting more people out there that are familiar with reinforcement learning, fuzzy, explainable AI, machine learning in general, and software development. So all those things. So that's one reason why we're going to continue. We're going to keep pushing to make the competition better. We're always open to advice or volunteers. Thank you.
Thank you, Tim. Professor Karimi, wrapping it up.
So thank you very much. First of all, again, thanks to Professor Kelly Cohen and also the Dr. Tim Arnott for this very informative presentation today. And me, myself, I enjoy to learn more about this topic. So because we work on the explainable in the machine learning, so it some approaches like deep learning, and of course some audiences. So from my group, so also now they listen to your presentation. Of course, we are looking forward to use more methodology from XFC, and hopefully we can improve our research. So again, thank you very much for your time and this very great presentation. And also it was a very good discussion to learn about this competition. So definitely, so when it comes to the competition and involving the students, so basically in this international platform, so the Journal of CES so would be very happy to take part in this kind of the competition and try to contribute. So they basically to encourage the students, so they basically to contribute. And of what we can do, as also the Kelly, he mentioned that the special issue and also some sort of the maybe advertisement on the web page. So this could be one way of the contribution from CES. And me myself also, I try to advertise this competition in Europe because we have a sort of the connection to some universities. And so this can be also circulated in our network, so internally and also through the web page. So of course, this meeting today, so it was an introductory meeting. So then these floors or this our opportunity is open to you anytime if you want to give further information, maybe in the future webinars. So because CS is planning to have some webinars every 2 months and try to promote some to provide more information about our publications. And when it comes to this competition, of course, we would be happy if you have some new information to share with us. So definitely, so you are welcome to give another speech next time if there is more information if you would like to share. So at this stage, so I would like to thanks again, so all of you and also the Professor Pede and also the team and also Kelly for this very informative discussion today. So I think from my side, this was a short summary. I hope everyone in our this live streaming and also in the Zoom, they also enjoy so this kind of presentation. And of course, if they have any question, any comments, any ideas, so please feel free to discuss with our distinguished speakers. And the CS would be happy to help and to make such an interface and to promote this activity. And again, thank you.
Thank you very much
Thanks
to
so
everyone
much.
who attended, and take care. Have a lovely weekend. Bye.
Same to you and have a nice weekend. Okay, see you next time.
Happy Friday.
Bye, everyone.
Bye.
Bye, everybody.
Thank you. Thank you.
Bye. Bye.